Experimental designs. A classic study about experiments is the Hawthorne studies. It was done by the Western Electric Company, and they tried to figure out how to increase the productivity in their factories. So they started changing around the light, started changing around different factors in the environment, and looked at how it influenced the motivation of their workers. And actually, one doctoral student at Fresno State had their grandmother that participated in that study. However, this lady didn't know that she was part of the experiment. She only learned that after the fact. So that was a good thing, right? Because that's one of the characteristics of a good experiment, that the participants don't really know what it's all about, and that way the experiment is not influenced. So why do we do experiments? It's to understand the world better, find out how things are connected. Experiments help us make decisions, right? We can evaluate different alternatives and decide which ones is likely the best one, or what are the results of different alternatives. We can use experiments to optimize products, workplaces, therapeutical methods, instructional methods. There's all kinds of ways to use experiments for the greater good. Now, the true randomized experimental design has different characteristics. That's the ideal study as it might take place in the laboratory. Now, in educational or psychological research, we can't always create a true randomized experiment, but let's look at what the characteristics would be. First of all, you got to be able to manipulate the independent variables. So that will be the context of the different situations. You got to be able to manipulate that. Secondly, the participants in your experiment must be assigned to the group randomly. If you don't have random assignment to groups, it's only a quasi-experimental design. So why is randomness so important? By assigning people randomly to groups, you eliminate potential biases that could happen through assignment by choice, or even factors that you don't know about. If you have a random assignment, then these factors are controlled for just by random assignment. That means that just by chance you would have similar effects in each group. Right? Let's say you have 100 people, you randomly assign them to two groups. The average age of these two groups should be about the same. The same with the gender distribution, it should be about the same. Socioeconomic status, the distribution should be about the same in these two groups, just because you're utilizing the principles of randomness. And thirdly, in order to be able to control potential influences, you got to be kind of able to shield your experiment. What are common experimental designs? You have, first of all, the very common design is a pre-test and post-test control group design. So the R in the beginning means random assignment. Then you have the upper line, which is one group, and the lower line is the other group. The circle means a test or a measurement. So it could be a survey, or it could be a measurement. For example, you measure the weight of a person, or you measure the heart rate, or you give them a certain ability test, or a depression inventory, or whatever it might be that you're trying to manipulate. And then you see an X, that's the experiment, the intervention, the treatment. And you notice that the top column gets a treatment, the bottom column doesn't get a treatment. And then after that, you again have a post-test. So you do the same test again. And there you can know, if you find a difference between the two groups, that your experiment or your treatment had an influence on the experimental group. The second design that we're talking about here is the post-only control. So you have the same thing, random assignment at the beginning, but then you don't have a measurement. You just have a treatment for one group, while the other group does not have a treatment, and then after the fact we have a post measurement. So here you save yourself the first measurement, but you're not 100% sure that your treatment, that your randomization really worked, and you also don't really know where your group started from, right? All you can say really is there a difference after the treatment? And then the third group here is the Solomon 4-group design, which is essentially a combination of a pre-test, post-test control and a post-only control. And here the advantage is that you can examine what the effect is of a pre-test by looking at comparing the first two groups with the third and fourth group. So you can test what the effect is of testing twice, right? Sometimes you give people, for example, let's say you give them a depression inventory or you give them a math test. Sometimes you have learning that occurs in your participants. So just by the fact to have being measured, to fulfill a test, to answer a question about depression, you might actually influence the participants. So that Solomon 4-group design will help you answer that question as well and control for that. We have a number of groups of experiments, so we can distinguish for pre-experimental designs. So these are not really experimental designs, but they are, like the name says, precursors of experimental designs. For example, you have a one-shot case study where you try a treatment and you see, well, does it seem to work or not? Sometimes you only have one group and you do a pre-test, post-test design and you measure the change. Or sometimes also you have an intact group comparison where you just look at the post-test. What is the difference? Then the experimental designs. There we say random assignment to the treatment and to the control group. And here again you have a post-test only control group, pre-test and post-test control group, and then also a factorial design where you include multiple factors in your design. The second big group is the quasi-experimental designs, where you don't have random assignment. So it's non-random assignment to treatment and control group, and therefore you might have certain biases. An example could be you're comparing different school classes with each other, where really it's not that random who is in which class, but maybe you are able to randomly assign classrooms to different treatments. Or maybe you look at different treatment centers in psychotherapy or counseling, and you can't really randomly assign the individuals to a different treatment, but maybe there's different sites that use certain methods, so the sites could be randomly assigned to using different methodologies. Then you can also look at time series designs, where you look over a certain period of time. You have multiple measurements and you look at how people develop. And then you have the after the fact designs, for example, correlational designs or a criterion group design. What are the advantages of an experiment? It gives the researcher tight control over independent factors and allows researchers to test key relationships with as few confounding factors as possible. And if done properly, it allows for direct causal testing, right? If you think that X influences Y, well, if you can truly manipulate X, move it up or move it down, and then see how Y reacts to your manipulations, you get a tighter understanding of what that relationship looks like and if indeed there is a causal relationship or not. The disadvantage of experiments are that you usually have a smaller number of sample size, right? The n is smaller, and sometimes you can't really generalize as easily because you're dealing with a smaller sample size again. And lots of times experiments require a lot of planning, they require training, and also they require quite a bit of time.